Today we will discuss about the like features. What are the great features are available? Why do we need to choose the Snowflake cloud data warehouse? See, very first one is great performance and scalability. Why we have a great performance? Yesterday also we seen that in the previous slide. You no need to take care of the tuning or handled by Snowflake only. Okay, why that specialty? Great performance and all. I will tell you. See, they have Snowflake has designed its architecture like that. Whatever you are saving, whatever you are storing a data or retrieving a data from the storage space, okay, without applying any tuning concepts, you can able to retrieve the data very fastly. Like, so next, like data is going to store in the column format in the Snowflake Cloud Data Warehouse. Data is going to store in the some storage components. By doing this, you can able to retrieve the very fastly. You can see the very good performance improvement in the all the requests. Very good performance in the all the requests. Okay, and one second, guys. And as we have a lot of advantage by storing the data in a column format. So tomorrow we are going to discuss about the Snowflake architecture. There I am going to explain you in detail, pin to pin all the details, how the data is going to store, what is the meaning of column format, and what are the benefits we will get if you store the data into the column format and all. And also see in on-prem servers, we store the data, and data is going to load day by day into the data warehouse and also into the storage disk. What will happen, guys? What will happen if the storage disk is going to full? What will happen?
It will further no data will be fetched to the online data warehouse.
Okay, still my question is, if the data is full, if the data no, if the storage disk is full, suppose you have a 1000 TB disk is full, then what is the impact?
So then we will not get the latest data because hard disk is already full.
No, not only a latest data, your server
The server, it
data
won't
warehouse,
return. It's an error, sir. It will throw an error.
it will
It
not
won't fetch.
respond. It will not respond. It is keep going to,
Yes.
suppose if you execute any select statement, simple select statement with the 10 records, it will not return the any data. Okay, it is not return the any data. Fine. It is going to the infinite loop. It is keep executing. That is nothing but it is not returning. It will cause a performance issue. So who is customers, the application which is mapped to the particular data warehouse, the customers can't be able to access the any data in the applications or in reports. They will escalate. They will escalate. I am trying to run the simple data. I'm trying to run the simple data, but it is not at all returning a data because of the hardware issues. Hardware hardware components are outdated. Suppose what will happen? You have defined a some 4 CPU cores, and then you have 15 GB of memory, and then you are processing, and concurrent users are connected to your server, and you are processing terabytes of data. what will happen? The predefined hardware resources are not sufficient for the your requests. Yes or no, guys? So that we will get the performance issues in the on-prem servers. To overcome all these things, we don't have all those problems in the Snowflake cloud data. Everything is taken care by Snowflake. Because see, I will give you, if n number of users are connected to the Snowflake, n number of users are connected to the Snowflake environment, and they are loading the data into the Snowflake environment. Based on the request, based on the data size, automatically the storage spaces will be allocated by the Snowflake environment guys. It is not going to stop you due to the storage location issue. No. If you are loading huge data, for that automatically the storage space is going to provided by the Snowflake. Now tell me guys, now do we get the storage space issue in this Snowflake environment? Snowflake cloud
No,
data?
sir.
No,
No.
because automatically based on the request, automatically the data will be no, automatically storage space will be allocated. Second thing is, as I mentioned, concurrent users are connecting to the Snowflake environment and they are submitting their multiple requests at a time, and they are processing huge data, terabytes of data. Now, here also, in case of a hardware resources, Snowflake is going to provide the required hardware resources for the all the concurrent users for all the requests. It is not going to stop you due to the lack of hardware resources. No, because that's why that is the beauty of the Snowflake. It will calculate internally how many number of requests are submitted and what requests are submitted, what is the request, what is the purpose, what is the task. Everything internally it will calculate. According to that, the hardware resources are going to provided by the Snowflake environment. Now tell me guys, by seeing all these things, do we get any performance issues in the Snowflake?
No, sir. No.
No, because of the Snowflake architecture is like that. They have designed the architecture is like that. That's why we see the very good performance. We have a lot many things. We have a lot many things. We will we will see one by one in our regular sessions. Okay, so that is great performance and scalability. Now, let me ask you. Now, let me ask you. Suppose. mm in on-prem servers, if you are not on-prem servers, example, take it as example SQL server. If you are not working in the weekends, is it going to save the resources or it will be up and run in case of a on-prem servers guys?
It will up and running, sir.
It will up and running because the system is like that. The system is, there is no option, there is no feature in the on-prem server that if you are not using, it will go into the disable mode like that. No, until you manually down the server 24/7, all the servers will be up and run in case of a on-prem servers. And whenever the servers are up and run, even though you are not using, though those servers are consuming a resources, and it is there are cost and then prices are involved when the servers are consuming a resources, unnecessarily spending the cost on the servers even though projects are not using the servers. Yes or no guys? So to avoid that, in Snowflake Cloud Database we have a option that is a scalability. What is this feature? What is this feature? This feature is whenever this feature is whenever this feature is whenever you are using the Snowflake environment, then only it is available. Whenever you are not using, then automatically it will go into the suspension mode. whenever it goes to the suspension mode, the pricing or cost will not be applicable on your environment. That is nothing but suppose you will be logging at 9 o'clock in the morning and you will be log off at 6 o'clock in the evening. After some time, automatically it is going to the suspension mode because you are not using. Then why do run the servers up and down until you use the servers or until the project use the servers? If you are not using, then no meaning of to run the servers, right, guys? If the project is not using, there is no meaning, right? Yes or no?
Yes, sir. Yeah.
So Snowflake has the option scalability. Whenever you are using, at that time it is available. Whenever you are not using, it will go into the suspension mode. Suppose you are working only in the working days, Monday to Friday, then it is going to work on Monday to Friday. If you are not using the weekends, it is going to suspension mode. And you are using only 5 hours per day, then it is going to available in the 5 hours. Now, whenever you are using, it is available. Whenever you are not using, it will go into the suspension mode. Whenever it goes into the suspension mode, then this environment is going to save the cost to your organization. Because it go into the suspension mode. Whenever it goes to suspension mode, then charges will not be applicable. That is the meaning of scalability. Okay. Next, zero management. I told you zero management. I told you the storage location. I told you the hardware resources. I told you the performance tuning architecture. You no need to monitor anything. You no need to manage the servers. Automatically, Snowflake will take care. Hardware resources, storage disk, everything, performance tuning. Automatically, it will take care. No need to monitor the servers. No need to monitor the database. Nothing. Automatically it will take care. I told you example storage space and then hardware resources and then performance tuning architecture they have designed like that. So in case of a on-prem servers, to monitor the servers we need a people. To upgrade the hardware resources we need a IT engineers. To upgrade the storage capacity we need a database administrators. Even though still if we get any issues in the database, then we need a database administrators. We need a human resources in case of a on-prem servers to manage the server. Yes or no, guys?
Yes, sir. Yeah.
Yeah. So in this Snowflake environment, we don't require any human resources to manage the servers. That's why we call it as a zero management. Next, convenient pricing. That's why whatever we use, we are going to pay for that only. What is the meaning that, guys? Whatever we are going to use, for that we are going to pay. That is a convenient pricing. What is the meaning? Based on the discussion. Devas is Kiran. Harsha.
Yes, sir. The one you explained, right? Like weekend, suppose if I don't want, so that is saved. So whatever I used on the weekdays, that only I am paying, right? That is the convenient pricing.
That is what. Simple in single word. Whatever you use, for that you are paying. Whatever you are not using, you are not going to pay. So that is a convenient pricing. In case of on-prem resources, not like that. There is no feature in the on-prem servers. Whether you are using, whether you are not using, always costs are involved. Yes or no?
Yes, sir.
So that's the problem over there. Unnecessarily, your organization is uh, 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 spending the cost on the servers. Even the project is not using. Even though project is not using. Okay, so that is convenient pricing. Next, virtual compute warehouse. Virtual compute warehouse. So this is the purely hardware resource in the Snowflake. Purely hardware resource. See, in the Snowflake, there are no physical components for the hardware resources. This is virtual compute warehouse. Virtual compute warehouse can be called as a hardware resources in the Snowflake environment. So this is also one of the object. This is also one of the object in the Snowflake. How you are creating a database, how you are creating a schema, how you are creating a table. Like that, you are going to create a virtual compute warehouse. That is the hardware resources. So while creating the virtual compute warehouses, you are going to create these virtual compute warehouses with the different sizes. See, based on the project requirement, in the on-prem servers, based on the project requirement, you will design the hardware resources. Yes or no, guys?
Yes, sir. Yeah.
Yeah.
Yes, sir.
So here also, based on the project requirement, you are going to create a virtual compute warehouse with the different sizes. Suppose you have a 20 projects. Out of those 20 projects, each project is requirement is different. One project may processing the huge data, and one project may having a huge number of users. In another project may don't have the many users. Based on that, the hardware sizes will be varies. Like that, based on the project requirement, you are going to create a virtual compute warehouse with the different sizes. And one more facility in the one more facility in this Snowflake is, suppose you have 20 projects in the organization. Those 20 projects are using Snowflake environment. Now, instead of sharing the same hardware resource, same virtual compute warehouse to all the projects, you can able to create the 20 virtual compute warehouse and then assign each virtual warehouse to the each project, so that every projects are using their own hardware resources. There is no shared concepts here. In case on-prem servers, wherever the server is deployed, that server is consuming the hardware resources, and then clients are accessing that server. Yes or no, guys? So hardware resources are shared in case of a on-prem servers. In the Snowflake environment, there is no shared concepts here. You have virtual compute warehouse. You can create multiple virtual compute warehouse, and then you can assign individual compute warehouse to the individual projects. So there is no common hardware resources in the Snowflake environment. What is the benefit here? What is the benefit, guys? If we are going to create individual virtual warehouse to the individual projects, what is the benefit? Any benefit do we have, guys? Devasis.
Uh, yes, sir. We have benefits on that.
That's I'm asking, what is the benefit do we have by using the individual hardware resource to the individual project?
Uh,
Harsha.
Load will not be there. Means only the single instant will be there, only particular related to the project.
Yeah, because see, whenever you are using the individual hardware resource, automatically you will be having a very good performance for all the requests, whatever the request, whether it is a data load, whether it is a data process, whether it is a data request, IO request, data modification, whatever it is, report generation, whatever it is. for all the requests, you will be having a very good performance because that hardware resource is specific to your project only, not for all the projects. Okay. By doing this, that's what. By doing this, you can able to see the very good performance improvement in the all the requests. We are going to create all these things. We are going to see in the further sessions, and we are going to create all this virtual computer warehouse and see how
Sir,
the
sir, I have a question. The virtual computer warehouse, that is it's a hardware, as you told. I agree, but the specific to some projects. Say, for example, 5 projects are there. 5 projects have 5 virtual computer warehouse, right?
correct.
Yeah. Okay. Suppose how we compare this with the on-prem. On-prem is using, although those 5 projects are, if it is an on-prem, then those 5 will be using the sharing, right? Sharing or how?
Same hardware resources. Yes.
Oh, same hardware resources. Okay.
I will
Same
tell you how same hardware resources works. See,
Okay,
you
because I
have a
need that
SQL server.
comparison, sir. Comparison, yeah.
You have a SQL server, okay, and suppose let's consider one projects. You have 5 developers. Yes or no, guys? Okay, and 5 developers are using the SQL server in your machines. Tell me the answer. Whatever you are using the SQL server in your 5 machines, is that client or is that server?
It's client.
Client instance. Client instance, okay, but server instance is available in the one place. That server will be accessed in your machine through the client instance, yes or no? To run that server, there is one hardware configuration over there. By retrieving the client instance, the server will be utilizing the hardware resources. How many client machines are accessing? Right, Ajay? How many client machines are accessing, and those client machines are accessing the server. That server is utilizing the hardware resource. So those client machines are utilizing the same hardware resources. Yes or no, guys?
So there's hardware resources at the client side, right? At the client base, not the server base, right?
Server based, na? To run your server, there should be one
Mm-hmm.
hardware configuration. Okay. But in your machine, simply you are accessing that client instance. That's it. Whatever you are requesting a data in your machine, that will be hit to the server. From there, it will be accessible. Okay.
No, that hardware is consumed by my client machine or the server. Server is the
Suppose
server is
suppose
this.
suppose let's consider this is a SQL server in my machine. Okay.
Okay, sir. Yeah.
This is client machine. Okay.
Okay.
Client machine.
Mm-hmm.
Whatever I am executing the SQL server.
Mm-hmm.
Okay. It is going to hit to the server, right?
Correct, sir. Mm-hmm.
Going to hit to the server, and
Mm-hmm.
to run that server, there are hardware resources. Yes or no? For the server.
Okay, yeah, yes, sir. At the server
Okay.
end,
Server. Okay. Now 5 machines are accepting the 5 machines are executing the SQL server. Yes or no?
yes,
Those
sir.
are
Yeah.
machines.
Yeah.
And those are accessing the same single server. Yes or no?
Yes, sir. Yeah, correct.
So
Mm-hmm.
for the single server, there is a single hardware setup. Yes or no?
Yes, sir. Yes, correct.
Now, is it shared or is it individual?
Yeah, shared only, sir.
Shared only. That's what. See, they will configure. They will design the hardware resources while installing the server. How many
Mm-hmm.
clients? How many clients are going to connect? Suppose there is a one server, and the architect will design in such a way that that server will be accessed by some 100 client machines. To support that
Okay. So,
100 client machines, that hardware resources will be defined, because that server is accessed by the 100 client machines. To up and run that server, and to support the 100 client machines, there should be enough hardware resources or not.
Yes, sir. Enough hardware resource. Yeah.
Enough hardware resources. That's what this is shared or individual now?
It's shared only, sir.
Shared only. That's what in case of a Snowflake, even though you have 100 people in the organization which are using the Snowflake environment, but 100 people are divided by the projects, 20, 20, 25 projects. Okay. For the 5 projects, 5 virtual compute warehouse will be defined, and then those 5 virtual compute warehouses are allocated to the 5 projects, and 20
Okay.
people, they are utilizing one virtual warehouse. Other 20 people, they are utilizing other virtual warehouse. Other 20 people, they are using other virtual warehouse. Other 20 people, they are using other 20 virtual warehouse. Now tell me, here hardware is individual or hardware is shared here?
Hardware is individual only, sir. Individual.
Individual only.
Individual.
Individual only. By doing this, what is the benefit is here is, as there is no dependency between as there is no hardware dependency between the one project to other project, whatever the users are connecting to the particular environment, and they are using only their own virtual compute warehouse. By doing this, you will get the very good performance improvement in all the requests. Yes or no, guys?
Yes, sir. Yeah, very good performance. But
Yeah.
in virtual computer warehouse for the Snowflake, because it's for each and every client, it's a separate virtual computer warehouse. So which means it won't occupy more space for each and every client, right? Because it's separate for each and every. It's not sharing, and it is a separate, sir, separate hardware, right, for each and every user
Not an
or
each
client
and every user, for the group.
or a group.
For the group, yeah.
Okay. Okay, for the group, okay, for a certain group,
I
yes,
told
sir.
you for 20 people, one hardware resource, one
On
one
hardware, sir. Okay,
warehouse.
okay. Instead of okay, the centralized sharing resource of the on-prem one, here the virtual computer, it's a group wise, like I mean 10 or 20 like that,
Like that,
segregated.
yeah.
Okay.
So based
Okay,
on
sir. Got it.
that, so the Snowflake is going to work, and then
Okay.
you are going to use your individual hardware resources. By doing this, you will get the very good performance improvement in all the requests, whether it is a data load, data retrieve, whatever it is.
Okay, sir. Okay.
Clear or not clear? Others? Debasis Kiran.
Yes, sir. I'm clear. Yeah.
Yes, sir.
Kiran, I'm not hearing your voice at all.
Yes, yes.
Where are you from, Kiran?
I'm from Bangalore.
Yesterday have you joined?
Yes, yes.
Okay. I told you to take the recording video, right?
I didn't get receive actually, but
Yeah, you can request them. They will give you.
okay.
Yeah. So this is virtual compute warehouse. Next one is recover Snowflake object using undrop. Now tell me, guys, Devasis or Kiran or Harsha. Unfortunately, without knowing, so you have dropped the one table. You have dropped the one table, but that is important. You should be require that table for your project requirement. Then what you will do? You want to bring back that dropped table. What you will do?
Maybe we'll contact DBA something, any flashback thing or those things they can recover it. Means normal on-premise.
Yeah, you will contact to the you will contact to the database administrator. Okay, and then so that DBA will identify the latest backup device, latest backup device, and then he will restore the deleted table into the database. Yes or no? So that is that involved multiple steps. You need to raise a request to the DBA, okay, and that request is approved by the multiple levels, and then the DBA will check the latest backup, and then he will restore. It is taking couple of time, and then there are multiple steps are involved. Yes or no? Multiple processes are involved. Yes or no, guys?
Yes, sir. Yeah.
Yeah, here in the Snowflake, to cut down all those process and then that time taking process, they have introduced the undrop concept. They have introduced the undrop concept. Undrop concept. How you are going to write a statement like drop table name, like that you can write a statement undrop table name. By doing this easily you can able to restore. By doing this easily you can able to restore. Easily you can able to restore the deleted table from the database. Simple statement. No need of circus. No need of round process. No.
Sir, okay, sir. So here, okay, for I accidentally dropped, so I use the undropped and get the table. Suppose if I want to completely remove, so I use intentionally drop. So how long that will retain? I mean, I want to completely remove that table at all.
That's okay. That is good question. There is a mechanism. There is a mechanism in the Snowflake. You can define while creation of a object. So how many days the objects can be how many days objects can be retained from the database. You can define that day. So till those many days that object is available, you can
Okay.
restore whenever you want. Suppose Snowflake will allow maximum 90 days. Snowflake will allow maximum 90
Mhm.
days or by default 1 day. By default one
Okay.
day. Yeah. Intentionally or unfortunately you deleted the object from the
Oh,
database.
I can configure that. I can configure that.
Yes. You can define that. You can define that
Okay.
period, that time.
Okay,
In
sir. Okay.
24 hours, if you don't define any value, by default it will suffer for the 24 hours. Within the
Okay.
24
Okay.
hours, whenever you want to bring back, then you can bring back.
Okay, sir. Okay. Okay.
So that is a mechanism here. So that is a undrop. Okay. Next,
Okay.
next object cloning. So this is also simple. 1 second, guys. I will come back. 1 second. I will be back. Guys, we are discussing about the object cloning. Now tell me, guys, one requirement. Example. This is your on-prem server. This is your on-prem server. Let's consider this is the test database and this is the production database. Okay. This is production database. You need to restore this database and create with the new database with the production dev testdb UAT. So this is the one live database already you have in this instance. you need to make a copy of this test database and restore it as a new database. That is for the development person, and one more is UAT purpose. So what we will do for this, Kiran? What we will do for this requirement? Usually in the regular process.
We'll create another database, right? Two different databases, one for dev, one.
Two different databases you will create. Then what you will do? By creating the database itself, you will not get the data, right?
Yeah, we need to move that. We need to create that one. Means whatever the objects we wanted to create, right? Both the dev and then that
UAT.
UAT instance we need to create. Means
Okay. What about the data? What about the objects?
everything actually. We have to create the data. We have to create the objects and all those things we need to create. Actually, two different instances.
Else, what you need to do? Take a backup of this database and then restore this copy of this database here and also restore here. So backup and then restore, backup and then restore. So that is a multiple process. Yes or no?
Yeah.
So to cut down that process in the Snowflake, you have a concept called that is object cloning. What you will do? You can just clone. You can just clone. You can just clone new. You can clone old DB to new DB. This is new DB. This is old DB. By using a simple clone statement, you can able to copy this database into this database. That's it. There is a simple statement. In a fraction of minutes or fraction of second, it is going to copy the one database to other database. That is a cloning concept. They have simplified here. There is no concept of taking the backup and then restore everything. Nothing. By using the cloning concept, you can able to copy one object into another object. Simple by using this cloning concept. Okay.
So that DB, so that cloning DB, like the new cloning DB has has the structure, objects, and data, everything,
Everything,
right?
bit and piece, everything. There is no option. If you copy this database here into, then whatever it has the DB, whatever it has the objects and data, it will be available in this place. And one more beauty is here. One more beauty is whenever you clone this database into this database, suppose now assume this is original DB. Original DB, it has 50 GB of space, and this is clone DB. It is also having the same 50 GB of the objects of whatever it is, whatever the objects we have data and everything, it is going to restore here. Now the thing is, as already it is taking the 50 GB. Whenever you clone this database, now guess or tell me guys, is it going to take the 50 GB or it is going to take extra or it is going to take less than this original size?
Maybe less than, sir. Maybe less than. I don't know why. How less than?
Maybe less.
But it's less than.
No, initially, as it is, you are cloning from this database to this database. It is not going to take any space because it will refer to this database and then bring the data for you. It is going to less space and it is going to take the space when you start to add the data or modify the data. Modify the data from clone DB. From that time onwards, it is going to start the take the space for this clone database. That is the beauty is here.
Sir, suppose if I delete the test DB, sir.
If you delete the test DB, now that is nothing but okay. Good question. This scenario I have not came across because the good question only. But the thing is, deleting the entire database usually will not be happen. But for this instead of giving the some random answers, I will cross verify and then let you know, Harsha. Okay? Because
Okay.
see, there is a dependency on this database. This is clone and then this is original one. There is a dependency on this original database. If this original database is deleted, then what will happen? That I need to check, because usually databases will not be deleted from the any of the environment. Yes or no? But
Yes, sir.
for your case, I will check and then clarify you instead of giving some assumptions. I don't want to give the assumptions answers. I will cross verify this cloning concept, how it works in case of a source object is deleted. Okay?
Sir, and one more thing. See here the testDB is there and testDB clone is there. Clone dev. So in that testDB clone, whatever testDB is there, the same object structure and the data, even the data records will be copied as it is. I mean, it's cloned as it is. So suppose if I don't want the records, I want only the tables and the objects. I want only the object. So is it possible, sir, that one?
No. Cloning means there is no options.
Okay.
Only you can get the structure. You don't want the data, then there is no that option. You can bring that objects as it is.
Okay.
Yeah.
Okay, sir. Yeah.
So that is object cloning here. See, this process is cut down. Copying and then backup and then restore. Those things under the traditional approach, old approach. It has gone now. Okay.
Okay, sir.
So semi-structured database means it is going to process the JSON, XML, all these data formats. It is going to accept all these data formats. It is going to accept and process data. Next, continuous data production, time travel. Now, 1 second. So this is the SQL Server and testDB. This is the table. These are the tables. Suppose let's consider you have some table here. Okay, example I'm telling you. From this table, you have a 10 millions of records or 1 million records in this table. If 10K records are modified, if another 10K records are deleted, as part of the requirement, you have done some DML operations on this table, and once you have completed the DML operations on this table, you have done the data validations. Whenever you do the data validation, you came to know that you have missed something else to apply some conditions while doing a DML operation. Due to this, more records are impacted rather than the less records. So you have modified the data. Now the data is whatever the data is modified, the wrong values are updated. Now what you will do to bring back that original data? You want to bring that original data and then restore that original data into this table because you have done the wrong modifications. What you will do? At least I will clear the question. Guys,
So, yes, sir.
usually if the data is modified or deleted from this table, again you will go back to the backup and then restore this table in the traditional system. In case of a Snowflake, you have a time travel concept. It is going to maintain the history. 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 From that history, immediately you can go back to the history and then bring that data restore into the tables. No need of restore and all. So that is a time travel. Data sharing. Suppose this is the account one. Like this, you have a account 2. In account 1, you have a tables. In account 2, you don't have a tables. You need to provide the access these table to the account 2. In that scenario, by using the simple data sharing concepts, you can able to provide the access to the data sharing. You can able to provide the access to the tables which are available in the account 1 into the account 2. So that is a data sharing concept. Next, snow pipe. Snow pipe means what? So this is the one of the object. This is the one of the object in the Snowflake. It is going to do the data loading process automated. If you get the n number of times source files into the source location, automatically it will pick and then load the data. This is not a scheduler. This is not a scheduler. Scheduler is what? Scheduler is going to run according to the scheduled time. If it is meant to run 4 times a day, then it is going to run only 4 times. But Snowflake is not like that. Whenever you provide the source files, or whenever you uploaded the source files into the source location 10 times a day, automatically this will pick that source file and then load the data into the target table. That is a Snowpipe. So
So
one second. These
yeah,
are the
sir.
good features. These are the good features are available in the Snowflake. And tomorrow we will discuss on the Snowflake architecture. Okay, Snowflake architecture. Now, tell me, someone is asking the doubt.
Yeah, sir. Snowpipe is there, right? Snowpipe, like it's a kind of observer, right? Observer. Like if anything
It is
comes, then
object.
this will get
It is the object.
object. Okay, it's an object. Yeah, object. And if it will listen, if anything happens, dependent on that, then this will get
in source file, in source location.
Okay, but that's why irrespective of times. That's what you told. 10 times or 20 times.
In source location, suppose you have configured between the AWS environment and then your Snowflake environment.
Okay, sir. Okay.
Your source is AWS, and while creation of the objects, you are mentioning your source is AWS environment, and that object is going to bring the data from the AWS. Instead of running the manually, whenever the source files are uploaded into that location, automatically it will pick and then load the data into the target table without involving any manual intervention. You will make the setup and leave it. It will do its own job. That's it. Someone is placing the files into source location, and you no need to bother about it. Bother about this. Automatically it will take care and then load the data.
So it's a kind of autosys jobs that from the source.
That's what scheduler is different. This is scheduler is what? Scheduler will listen you only when if you schedule. Yes or no?
Schedule the time. Yeah, correct. Schedule the time.
Yeah, in a day, suppose intentionally you created the scheduler to run twice a day, then it is going to run only twice a day.
Yes,
to overcome that, additionally, to provide the extra feature, this is Snowpipe. Right.
Okay, sir. Okay. Sir, and these 2 points only I don't understand. This continuous data protection and the secure data sharing, right? These two I don't understand completely.
Simple. Continuous data protection, that is time travel is there, no?
Yeah, time travel. Time travel means any historical data.
One second. That is time travel. So don't think much. We are going to discuss all this. We are going to create and then show you everything in the further sessions.
Okay.
Delete the data. If you delete the data from the table, data is gone. Okay. Data is gone. That delete request is maintaining in the history. Okay. The history of the Snowflake.
I can restore that.
You can go back to the history and then identify the request whenever you have done the that delete operation. You will find that delete statement and bring that you will the query ID, and then you can query the data. Before that query ID, whatever the data is there, you can able to bring that data and then restore into the original table.
So this time travel, like if I am a Snowflake developer, I myself can do, or I need to go for some DBA.
No. You can do.
Okay, sir. And the secure data sharing within the Snowflake cloud account.
But this is separate environments. You have your own environment. Kiran has own environment. You have a tables. Kiran don't have a tables. Kiran wanted to access the tables from your account. So for this, by using this data sharing concept, you can able to do this mechanism.
Oh, I can provide the access to Kiran so that Kiran can
Kiran
access
can
my,
able to Kiran can able to access your objects into his account.
Okay, okay.
Yeah.
Okay, sir. Okay, okay. Okay, sir. Yeah.
Chalo, then we will meet tomorrow. Then we will discuss the Snowflake architecture. Okay.
Yes, sir. And one more quick question, sir. See here, the Snowflake is there. Suppose if I have a project, so now my project is running in on-prem server Oracle. Okay, but there is no reporting, nothing. Okay, but can I remove that on-prem server Oracle at all? And can I go to Snowflake and storing my data into that Snowflake directly?
That is what the migration, na?
Okay, so which means I don't want this Oracle at all. On-prem,
That's
I
what
don't want Oracle.
yesterday we discussed, right? You do migration and then you do decommission the on-prem servers.
Okay, so I can use my Snowflake as a database.
Yes, Snowflake.
Because Oracle has many features like RDBMS concept, relational database. So it has that atomicity, acid properties are there. So those acid properties the Snowflake will support.
Everything it is support.
Okay, okay. Okay, sir. I can tell this is a data warehousing or it's a relational data warehousing or something relational.
This is
Because
data
RDBMS
warehouse.
data warehouse. Simply I can tell it's a data warehouse. Okay.
Yeah. We will discuss, Harsha, whatever you have doubts, we will discuss tomorrow. Okay.
Okay, sir. Okay, sir. Yeah.
Hello,
Thank you, sir.
thank you. Bye bye. Have a nice day.
Thank you, sir. Thank you. Thank you. Thank you.
Yeah, yeah.
Bye. Bye.